Hello friends, welcome to evigyan. In the previous video, we learned about dimensions and the principle of homogeneity of dimensions. Today we will see why dimensional analysis is so powerful. Because using dimensional analysis, we can derive physical formulas, check whether equations are correct or not, and even solve problems without knowing the full theory. So let's start. Dimensional analysis helps us to derive relationship between physical quantities, check the correctness of equations, convert one system of units into another, and understand how different quantities depend on each other. Let's now see how this works with some clear examples. First example is the time period of a simple pendulum. Let's derive the formula for the time period of simple pendulum. From experiments, we know that the time period t depends on the length of the pendulum L and the acceleration due to gravity g. We assume that t is proportional to L to the power a times g to the power b. Now let's try the dimensions. Dimension of t is t, L is L, and dimension of g is Lt minus 2 because g is acceleration here. So we write t equal to L to the power a times Lt minus 2 to the power b, and which becomes t equal to L to the power a plus b times t to the power minus 2b. Now we compare powers. For time, minus 2b equal to 1, so b equal to minus half. For length, a plus b equal to 0 because there is no length in left hand side, so a equal to half. Therefore t is proportional to under root L upon g. Dimensional analysis gives us the form of the formula. But in the actual formula, there is 2 pi here. The numerical constant 2 pi comes from the experiment, and that cannot be predicted from the dimensional analysis. So you can say this is the limitation of dimensional analysis, and it cannot give you the constant part. Now let's take another familiar equation, that is v equal to u plus at. Dimension of v is Lt minus 1, dimension of u is Lt minus 1, and dimension of at is dimension of a times dimension of t, and which is equal to Lt minus 1. All terms have the same dimensions here, so the equation is dimensionally correct. So we observe here that dimensional analysis is powerful, but it has some limitations. It cannot give numerical constants like 2 or pi or 2 pi. It cannot tell whether quantities are added or subtracted. It cannot distinguish between a scalar and vector quantities. Still, as a checking and estimating tool, it is extremely useful in physics. Dimensional analysis teaches us an important lesson. Physics is not about memorizing formulas, it is about understanding relationship. If you understand dimensions, you can often rebuild formula from scratch. In the next video, we will move ahead and talk about significant figures and measurement errors, a very important topic for experiments and numerical accuracy. Until then, keep thinking, keep questioning, and keep enjoying physics. See you in the next video.